Okay, so welcome to this little walk through the quad-cropped flight simulator model for the Mambo, and there's a number of building blocks you'll see in front of you. The only one that we're interested in is the one in blue here, but we'll go through them. This is a signal generator, which is quite complicated to use, and we don't need to use. We can use a simpler way of generating the signals inside this box here. There's a flag here, which if the drone goes into a crash condition, it sets and stops the simulation. This is a non-linear airframe model of the drone. This is a sort of display of what the drone's going on. Here's some sensor dynamics here. So that's the overall block diagram. The controller, this is the controller here, outputs some values into the non-linear model. They're measured by some sensors and then fed back into the model with some environmental conditions associated with it. Now, if we double click on this box here, we get a control box, and this is another one that we need to look at. So we double click on this again, we get another set of boxes coming up. Now in these set of boxes, the two that are interesting are this one here and this one here. Now this one we can use to change set points, and this one we can use to change controller gains. So when it says controller, that controls the controller gains, and this one can control set points in a simple way. It's easier to use than their signal builder. So if I click on this one, you get, this is the, now this variable here is x, this is y, and this is z, height. Z is height, and it's got negative z. So minus 1.1 is like 1.1 meters off the ground. And you can play with these, and you can add things in here, quite simple adds, plus and minuses, and extra ones of these to generate profiles. So that's how I recommend you put different set points at different times into the model. Just to give you an idea, if we click on this one, you have a step time and you have an initial value and a final value to that variable. When you're ever using these, you've got to use a sample time of 0.005. So that's the sample time for the system, and you've got to use that. So if it says sample time anywhere, make sure it's 0.005. And that will then, this part here, we can expand out around here to do different set points. At the moment, it just does a set point change in height of 1.1 meters. So if we go click on here, we can go back up a level. And if we click on this box here now, this is the overall controller. And there are a number of control loops in here. There's actually 6 PID controllers in here. So if we look at this one here, first of all, this is our altitude controller, and there's our PID gains. So if we click on one of these numbers, we can change the proportional gain to something else. These are quite good numbers, these, so you can change them. You need to change them in your project, but for the moment we can leave those fixed. So there's the PID gains on the altitude controller, which controls the height. If you put more D in, it'll go up slower, more proportionally go up quicker. And if we go back up a level, over here now, this is the yaw control. And so there's the PID on the yaw control. This one has a saturation here, mainly to stop. If you make a very big change in yaw, it limits it so that it doesn't yaw too quickly. If you make the drone yaw too quickly, it'll crash. So this is like a limit to about 20 degrees a second. So just make sure you can't yaw for any more than about 20 degrees per second. So that's you can have a play with those gains, and you could change this saturation. There's 4 things you could play with there on the yaw control. And then this is an inner loop controller on pitch and roll. So look at that. Now this has got 2 signals down here. It's like this uses one line, but there's 2 signals coming down it. So this has got pitch and roll, and this is like a proportional gain on your pitch and roll control system. So if you click on that one, it's got, you can't quite see it, but it's got a proportional gain of 4 on this in both loops. Click on this one, it's got two gains now, one for pitch and one for roll. I'd have them the same, but these are the values that MATLAB have set. So there's the proportional gains, there's the integral gains, and there's the derivative gains. There's your PIDs. Those are your PIDs then for the pitch and roll. But then as additional to that, the pitch and roll, there's wrong box. This box here is an XY coordinator. So what you do is in order to change an X or Y, you pitch and roll the drone, and then it moves in that particular direction. But you've got to, so this is a slightly more complicated box, this one. But this has also got some PID gains in. So if you look at that box there, again, it's got a PI controller in there, it's got PI gains in there. So you can change those. And you've got just a proportional gain there. So you can change that one. And then this box here, this one takes in yaw and the Earth axes and converts that into XY for the drone. So as you change your yaw, the X and the Y have to change. This is a sort of box that can, if you know the yaw and you know your current Earth orientation, you can convert that into X and Y. So have a quick look inside that. It's just a function using causes and sines, which you've probably done that sort of thing in flight dynamics. So there's the control system now, or the different control systems. It's all inside here. So we've got the height, the yaw, pitch and roll, X and Y. They've all got PI or PID gains in for you to tune. So there's quite a lot of things you can tune in there to get your controllers running. In the top box here we have the run time for the simulation. And then what you can do is when you're happy with your gains and things, you're happy with this one just goes up to 1.1 meters and then hovers and then descends. So we're running it, going to run it for 8 seconds, and you click on the run button here. And it takes a few seconds now to actually run this. And this one's got a bit of visualization as well, but we're not using it. So it's got that red line it looks at on the ground. It's just getting higher now, so it's moving away from it. Just close that down a second. So when you've run that now, you now go into the MATLAB command environment. So you can click down there, it's onto the MATLAB box, and go across here, and you get the MATLAB command environment. And what we need now is a program to analyze the data. So MATLAB's generate a whole lot of data now, and I'm going to try and find that program. So the program I'm using is low down here somewhere, and it is Mambo Simulation Data Plotting 2021. So click on that. You'd have this stored on your USB pen or something. And if you make data now equal to RT estimate signal value, this is a little program now that's in MATLAB. You don't have to mess with it too much. If you get RT there, it stands for real time. So this is data from the real drone, where if you've flown it. But if you don't have RT, you just have estimate, it's the simulation. So if you put a % sign in front of a line, it stops it from running. So I'll put a % sign there and remove this % sign. So now the data is coming from the simulation now. Now what this graph does, it reads in the data, and then down here it plots 4 graphs for you. So let's have a look, and it plots height, X and Y, and yaw. So to do this, you click on the run button. You could modify this if you wanted. Click on the run button, and suddenly up comes, this is the change in height up to 1.1 meters. There's the change in X. There's a change in Y, and there's a change in yaw. So you can see these signals here, the 10 to minus 3, 10 to minus 3, 10 to minus 4. In the simulation, it tends to run very beautifully. And then if you did edit, copy figure, you could then paste that then into a Word document. So if you went to Word, see how it works, go into Word and get a new document, and then you could paste it in, and then you've got your graphs now, height, x, y, and yaw in radians, into your little report. So you make that a bit smaller maybe, like that, and change its size. And if we go back to it, if we close that. Now previously I ran the real drone on the same conditions. So if I change this program now to the first line, where it's RT, and then put a % in there. So it's now going to read the real data. I flew this with exactly the same gains on the real drone, and it ran. And now I'm going to run plot. I've downloaded that data. Download that data. You click on a little file in here called RS data, which I can't see for the life of me, but I'm sure it's there somewhere. You click on that, and then it loads that program in, and then it'll run this code for you, but this time with the real data. So this is a real data now that we've run the drone. Obviously to run the drone is going to be more complicated, and that's a separate video. But I just thought for interest point of view, it'd be nice to see the simulation and the drone as well. So if we run this now, and here's the real one, so you can see this is the change in 1.1. It's a little bit slower than the simulation, and there's a little bit more departure in X and Y. It's about 10 centimeters, 20 centimeters. These are in centimeters, so it's not much. 20, it's not much of a movement, and there's a little bit of yaw as well. So if we then did edit, copy figure, and then went back to our thing here and did a paste, then change the size of this a bit smaller, maybe make this one a bit bigger, and then we can compare. Then there's the simulation, there's the real, there's the simulation there for X, there's the real for X, there's the simulation for Y, there's real Y, there's the simulation for yaw, there's real Y. You can see it's not too bad. It's a little bit, the simulation's a bit slower, isn't it, than the real drone, so it's probably a bit heavier than it thinks. But that shows you now how you can get some results now from the program. Let's just go back to that program a second. The only thing you need to know about this program really is the numbers here. You don't have to change much. 1, 3 is height, 1 is X, 2 is Y, 4 is, I don't know what 4 was, but 5 is your, what's the other thing we might want to measure? Probably number 4 is pitch angle, and number 6 is probably roll angle. But these, you can change the numbers there, but I wouldn't worry too much about it. I can tell you what the numbers are, I can't remember now. But these are the numbers. The only thing you need to change, if you want to change the graphs round, would be these numbers. And then you can also change these words here, like height, or X, or Y, or yaw. The rest of the program you can leave untouched, and you just swap it between these two to plot out real data or simulated data. I'll give you a copy of this program, so it's quite straightforward. And that then gives you an overview of how you can use the Simulink. If we go back to the top level, this is the Simulink Mambo simulation, and how you can play about with this to run simulations. When you're doing the real flying, I'll just give you a quick demonstration how to do the real flying. You go to here and you click, and then you go on to, we click on that box there actually, and then do open as top model, and then go on to hardware and click on this button here, and then click on that button there, and it will then have a go at trying to download the code into the drone. Now mine won't work because I've switched the drone off, but this is what would happen, and it would then come up with a little window. Probably go this far, I don't know, maybe my drone's still on somewhere. You hear a funny noise and you know the drone's taken off. You then set this to 100%, you can change that to 100%. Click on Start and the drone will fly. And when you've finished flying, you click on MATLAB File, it will download the data from the drone into MATLAB, and then you'll be able to plot out the real data. But there's a separate video on this, so don't worry about that too much, but that's how that part works. If you close that, then you can get rid of it. So that's an overview now as to how the simulation program can be used. Maybe if I just do one other thing, if I go back to simulation and go back to here, let's just do one more thing. We go to here and then into there and then into here. If we're going to put more complex maneuvers in, what we do is take that across there and then go onto here and go onto commonly used blocks and get a plus and minus sign. One of these here. Get one of those across and then say delete that line there. Cut. And then put this in place. Then join that up and join that up. You can take one of these, copy this, say, copy that, and then paste it, and then move that down there, and then join this to here. So what we could have now is, if we look at this one, this is the X coordinate, say. So we could have the X going, say, at 5 seconds to a final value of 1. And then at, say, 10 seconds, we could have it going to 2. So what happened was up to 5 seconds, it would just sit there. Then after 5 seconds, it would move in X direction 1 meter. And after 10 seconds, it would move to 2 meters. So you could make a more complex move. So just by adding these in, you can make more complex moves. You can either more complex ones there will give you an X movement or Y movement actually. This one will give you an X movement and that'll give you height movement. So if you want to change the height up and down, you could just add things like this into there. And as long as you make sure that this one now has got a sampling time of 0.005, it will run beautifully for you. So that's how you can put different commands into your drone to see how it works for different mission profiles. And you can time them off the timers. You can change the run time here. Now, if you go beyond about 22 seconds, the drone can only store data for about 22 seconds. The memory on board the drone only has about 22 seconds of capacity because it's storing every 0.005 of a second, which is 5 milliseconds. So it's storing about 200 points of data per second, and it only has capacity to do that for, there's loads of pointers of data as well. So it only has capacity for 22 seconds. So if you run it for beyond 22 seconds, you can't see what it did. So unfortunately with this drone, you can only really up to 20 seconds would be safe. You could get a flight for about 20 seconds, do a different mission profile for that 20 seconds, and you could plot it and see how it worked. So that's a little introduction for you. Hope you enjoyed that. You can have a go now downloading your own copy of MATLAB, your own copy of the drone, and have a go running it. Now be careful now to make a note of your controller gains, because what I found is sometimes you change the controller gains, you change 2 or 3, and you forget what they were before, and when it runs, when your new gains goes unstable, and then you've forgotten what your gains are. So recommendation would be to go over here somewhere, go into here, and go into these boxes and screen dump these, so you know what the numbers are. So then if you do muck it up, you can always go back to these numbers. Just save your time and heartache. Because once it goes unstable, unless you go back to some sensible numbers, if you've forgotten them, it stays unstable forever, and this never works then. And that can be a right nuisance. I've done this myself. Only today did I find this version that worked. But anyway, it does work now, and I'm very happy. So I hope you're happy too. Okay, so on that little note, I'll say thank you very much, and we'll move on to the next set of videos.